So we thought that it would be perhaps beneficial to share information on some of the criteria that we use when we're selecting solutions and talking a little bit about what causes us to deviate from that. So today we're going to talk about drivers for how we solve problems, but we're going to illustrate using 3 use cases some of the points that we bring up, and also talk about what kind of challenges those things present for us, what kind of costs, but also what kind of benefits. And then at the end, talk a little bit about our architecture and how that's laid out. So one of the very first things that we think about when we're looking at solutions is we have to keep in mind that if you can't meet the need and meet the clock, you actually lose the business. So if we have our faculty senate come to us and say, hey, we want the library to be the place where you're offering data services, and we don't step up to the plate and actually be able to provide a solution in the time that they expect, we lose the business and they go somewhere else. At the same time, we can't drop the ball. You know, we have production services that have to be secure, robust, and reliable. We have to have new development, not only for the maintenance, but also for all these new things that people are coming to the library and asking if we're capable, able to do. And at the same time, we have to meet institutional, state, and federal guidelines. We're constantly looking at ways to reduce risk, and I'll just list a couple of things that we at the University of Virginia do to reduce risk in each of these areas. You know, we believe in community-driven development and open source and leveraging open source wherever possible. We do manage our code. We believe in the ethos of for the academy, by the academy. Hardware, I don't think there's anything that would surprise you there. Minimizing single points of failure applies to the human element as well as to hardware. And then in our content, you know, some of this has to do with preservation, but it also has to do some with reuse. You know, are we using persistent identifiers? And I don't mean Fedora identifiers. Are we using persistent identifiers so that people can leverage our content and not have things break and not have things change necessarily when we decide that we need to change things on the back end. And then there's things that the University of Virginia Library has just decided, these are stances we're going to take. We've decided that we want one global search interface across all of our content, whether it's licensed, whether we own it, whether it's described in our catalog. And we are very active in a lot of different community-driven open software, but particularly with Fedora, Solar Blacklight, Hydra. These are some of the solutions that we leverage. Archive space, and then consortia-based digital preservation. We believe in doing things with other people and not going it alone, except in rare case. And we believe in interoperable components because we want an architecture that is flexible, that it interoperates with a variety of things that emerge and become available and are best of breed, and going with things like standards and APIs and new things that emerge like the IIIF capability are things that allow for that kind of architecture. So you may say, well, you know, if you're a Hydra institution, a Fedora institution, why would you attack every problem using that kind of framework? And we do want to do that in the long run, but in certain cases, we've got that little red-headed girl being chased by the clock. And so we're going to highlight, you know, some of the things that we do, like what do we gain, what challenges do we occur when we deviate from our normal process, and we want to use 3 use cases to sort of highlight answers to those questions. And the first one we have is around research data, And our director for scholarly repository services, Ellen Ramsey, is going to talk about that.
I really don't know where she found that picture for me. So I run scholarly repository services at UVA, and that is a suite of services, several of which are under the Hydra umbrella, some of which are currently not, and there are some reasons for that we're going to talk about today. The services that you see in white are ones that we are currently running, and the one in the middle is our electronic thesis and data and dissertation service. And that's currently being developed on Sophia 7. It goes live July 13th. The traditional IR content is in our Fedora4 repository, and that will be the next thing to get built out in the Hydra head. And the one that we're going to talk about today is our data repository. The other two are just kind of twinkles in my eye right now. So, as Robin said, why is a Hydra institution choosing things that don't glue into Hydra infrastructure? Just to clue you in to where we're leading with this presentation. It's about time and features needed. It's about we needed a solution for federal requirements, university requirements. And when we did a full environmental scan about a year ago, the results, because of our timeline, because of our requirements, pointed away from Hydra for now. And this is really about modularity. What were the drivers that pointed us in the direction that we went? The ones that you would expect, right, as Robin covered. We had a lot of stakeholders with a finger in the pie. One of the most important things to our research office and our IRB was that data be stored locally at UVA. And so the product that we chose, the solution that we chose has that option, and we are hosting it locally. One of the things we were really interested in was integration with the Open Science Framework. UVA is in the midst of working with them, and we really wanted APIs that worked back and forth. Funder compliance was an issue for sponsored programs. We had some super fun hoops to jump through for authentication with University IT. Our local researchers wanted things that could be found easily, and as Robin pointed to, we are using a central search solution for that. People wanted things that are easy to reuse, and I think the guys at Stanford did a much better job talking about that than I did. And then the library just had a couple of requirements. So evaluation criteria are pretty much what you would expect. When we did our environmental scan, we looked at a number of solutions, and these were the things that we weighed each product against. And the contenders, the top contenders that came out, because of time, because of the usability, local storage, those kinds of things, were Dataverse, the data aspects of Sophia, and DSpace. Time-wise and solution-wise, we chose Dataverse. And you can see it was ready, right? It was a very, very short turnaround for us to configure it and get it up. It took us about 3 months, which, given all the hoops that we jumped through for authentication and local space, that was probably the most difficult part. Putting the thing up wasn't that hard. It did fit our user needs. Based on our, we did an A/B test of configuration for how to structure what went into what container for users, and got some uses out of that. It does produce solar indexes, so it does go into our central search tool, into our Ruggaber library catalog. It does have interoperability with the Open Science Framework, although we're still working on the API for version 4, which is the one that we implemented. We work for free. So, and I got email yesterday that I think it works now. And it's a known brand. which was kind of helpful for recognition for use from researchers. Some compromises. It is open source, but it's like 2 guys. And so they've been fantastic, but there's only 2 of them, right? And so, only a couple of them. Changes that we've needed and development isn't on the scale of what you see with Sophia, with Hydra, those kinds of things. So that's been an interesting experience for us. It doesn't interoperate with Fedora out of the box. We know that. And in some ways, it's not exactly purpose-built, but we were able to configure it in ways that really worked for us, because our interest in this particular tool was for publishing of data, not necessarily for collaborating. We're really going to use OSF for the collaboration piece. Just to give you a sense of what that clock was that was chasing that redhead, this is a graphical representation of the development plan for what we call Libra 2, which is the new generation for our scholarly repository. And there's a few moving parts. So the teal is our data implementation. And you notice that that's done. The yellow is our ETD implementation. And that's almost fully developed, and the launch, as I said, the soft launch is in like 3 weeks, which is why I'm the only one from that team who's here. And then, the next phase of development will be our open content, with artificial IR. And I don't know what the answer to that's going to be yet, because it's time for another scan. But it has some ideas, especially after this week. So, thanks.
So the other thing I wanted to say before we move on to the next use case is UVA implemented Libra 1 on a very, very early version of Hydra. And then we drove on through different content types. And so we had gotten to a point where we could not upgrade that particular full-featured Libra implementation anymore. And because we had not kept up with all the various upgrades, it came to a point where we were going to have to replace it wholesale either with a whole new Hydra stack or other components. And so this timeline that, Ellen showed is actually, the big win out of Dataverse was actually buying us time. Bought us time so that we could actually work in parallel. We could get one piece up quickly. We knew from our first implementation of Libra 1 that it absolutely was not meeting the data needs. We only had the capacity to do like 100 megabytes. And at that time, which, consider 5 years ago, people were just talking about research data and how libraries manage it. And they weren't, the researchers at UVA at least didn't even really know what they wanted. And at that time, the research showed that all the data sets were under 80 megabytes a piece, that there were, it will upload a variety of files. But we've learned a lot in the last 5 years about what researchers want around data, and continuing to learn, and we feel like this has bought us time to actually provide them something that's more useful than what they had in the past, and it will also allow us time to work with other partners on other consortial types of support for research data. So the second use case we want to talk about is at-risk web content, and this question came up in the last session. Should you really be saving all those reuses of your data? And another area that UVA did not have any technology to actually support was web archiving. This was sort of an easy partnership, because when we looked at Internet Archive, it's the kind of organization that has a mission that is very much aligned with ours, and they have the technology that was considered, best of breed. Why would you do your own when they have the technology to do this, to crawl your websites, to disseminate it at their site if you choose to have it public? had lots of flexibility to allow us to decide what should be public and what shouldn't. And they were building APIs to actually allow us to retrieve that data, both the works, so that we could put it in our preservation pipeline, but also the preservation metadata, even though it was minimal. And they're working with us to actually enhance that preservation metadata and get it to the level that we want. We're putting all of that in AP Trust. And they're working on another, I think with Stanford and other partners, an API to allow us to get the descriptive metadata back to support our general search portal. And I would say that is the challenge, is that they didn't have that from the beginning. And so that blocked one of our major stances, that we would have global search for everything. But at least they had that in the plans, and were able to work with them and help them specify that. And we've been available for testing. So this is a type of challenging use case in that we didn't have a solution, but we had a partner that we could work with. We don't have to build it ourselves, and it meets a lot of our other criteria for things that we've decided that we need in order to take a solution like this. Our next use case is around cultural heritage. Many people, well, anyone who lives around Charlottesville would know that the university went under a major renovation of the rotunda, which is a core campus piece that was part of the original university. While the rotunda was being renovated, our clever people from the library that are into gathering point cloud data went out with drones and other things and gathered lots and lots of data during the renovation of the rotunda the last several years. And they wanted to make that available somehow. SCI-Arc is a cultural heritage organization, and because we're a World Heritage Site, they said, we want to help you out with that. And they have technologies. They've taken our data, they've actually created images, they've processed it, but we have a few more challenges here. It's great that they use the technologies that they have is to process the data and put it up on their site and showcase it with a lot of other World Heritage Sites. But the exchange has been totally physical. We have to ship on disk the data to them, and anything we get back from them, we have to have data shipped back to us on physical media. There's no APIs, and there's very, while they're willing to provide guidance on how to use tools and how to use technologies, it's been not the kind of interaction that we have with Internet Archive in terms of talking about APIs and talking about other possibilities. And at this point, I think we have plans to actually stick the multiple data in Dataverse and at least have it searchable so you get to the data sets, but that's not what we want. What I would like to see in the future is actually us working with the IIIF team to actually extend out that specification to include 3D image viewers and image sorters, and actually provide a Hydra instance to actually be able to showcase this kind of cultural heritage data set information. But we're going to continue to work with SCI-Arc. The other thing is they're only looking at cultural heritage, and I think many of our institutions have all kinds of multiple data that could benefit from us actually extending those specifications and providing something through our other common channels of consortial produced work. So just want to talk a little bit about Fedora4. Overall, our platform, we think of Fedora as sort of a train switching station or a river, which all these streams run into. So if you think about our architecture, we've got, digitization processes coming in at workflow. We've got Born Digital, we've got Hydra apps for ingest. We've got a lot of information coming in, but it's really Fedora that captures all this and makes it available to feed back out through these channels and to relate those objects, and also has the potential to relate across institutions because it is a linked data platform. And It also feeds our preservation workflows, and if you're interested in more the mechanics of that, Mike Durbin, our repository manager, will be presenting tomorrow on those topics. But I just wanted to say a little bit about that architecture, and we are still committed to Fedora and the hybrid community, but we're being very judicious about these other things that we're doing, when and why, and what benefits we're getting out of it.